Hello everyone, welcome to our channel, and in this video we'll be introducing the topic Euclidean geometry. So this video you'll find it on our channel under the Euclidean geometry playlist. So let's go straight into it. I'm going to start off by defining the term geometry. So geometry in Greek is pronounced geo, then metria. Geo meaning earth and metria meaning measure. So geometry as a whole arose as the field of knowledge dealing with spatial relationships. Euclidean geometry deals with space and shape using a system of logical deductions, which we call theorems. So Euclidean geometry was first used in surveying and still is used for that. Euclidean geometry is also used in architecture and to draw new buildings. So that is why Euclidean geometry is quite important. Other uses of Euclidean geometry are in art and to determine the best packing arrangement for various types of objects. So let's start off by defining the different angles we get. An angle is formed when two straight lines meet at a point. So if we can look at this triangle, we can see that line BC, which is a straight line, and DC, which is also a straight line. So two lines meet at a point D, then there's an angle in between there, and there's an angle at B and an angle at C because two lines meet. Angles are also known as vertices. So in this case we have three vertices, or we have three angles, so angle B, C and D, because in each case two lines meet to make an angle. So angles are labeled with a caret on a letter. For example, in this instance we are going to be looking at angle D. So let's say we want to denote angle D, or we want to write down angle D. So you write the letter of the angle and a caret on top. So that's how you denote angle D. Let's, for instance, now we want to label angle B. This is how you would write it. And angle C, you would write it like that. So angles can also be labeled according to the lines that make up the angle. So according to these lines BD and DC that make up angle D, this is how you'd write it. So the angle you're talking about always has to be in the middle. So in this case we're looking at angle D, so it's D and accompanied by the other letters of the triangle, so B and C, and in the middle D has a caret on top. So we are talking of angle D in triangle BDC. So yes, as time goes on, writing the full name angles or angle is going to be time consuming. So there's a symbol for angles that is recommended to use. So this is how you denote it. So it's right there. So it's just a line followed by another line but touches at the same point, and you don't have to put the dot inside. Angles are measured in degrees, which is denoted by a small circle there. So if, let's for instance, we're talking about 35 degrees. Let's say angle D is 35 degrees. So this is how you'd write it. So you'd say D, angle D with the caret is equals to 35 degrees, and the small circle is sort of in the air. And so that's how you denote angles. So now let's look at the different kinds and types of angles we get. Our first type of angle is the acute angle. That angle is an angle that is greater than 0 degrees, so it's bigger than 0 degrees, but less than 90 degrees. So if you were to draw it, it would look something like this. So this angle right here, so this angle here would be greater than 0 degrees, so it's in between 0 and 90, but it's never 90. Then we get our next type of angle is the right angle. That angle is the angle that is equals to 90 degrees. So this is how it would look. And this angle here is 90. That is the symbol for a 90 degree. So if you want to show in a diagram that this angle is 90, you are allowed to put that box on that angle. So that denotes 90 degrees. And then our next type of angle is the obtuse angle. The obtuse angle is an angle that is greater than 90. So it's greater than the right angle and the acute angles, because it's greater than 90, but it's less than 180. So it's not bigger than 180 degrees. So it's in between 90 and 180. And this is how it would look. So something like that. 90, greater than 90, right? So something like that. It's greater than 90, but not bigger than 180. Then our next type of angle or term is the revolution. The revolution is the sum of angles around a point. So if you have a point A, and let's say there are lines that form A, there are lines that divide the angle A. This angle plus this angle plus this angle plus this angle makes a revolution. So a whole revolution, meaning a circle. So it makes a revolution, and if you add all those angles together, so this angle plus this angle plus this angle plus that angle should give you 360, because that is the sum of angles around a point. Our next term or angle is the reflex angle. The reflex angle is an angle that is greater than 180 degrees. So it's greater than 180 degrees, but the angle is less than 360 degrees. So that angle would look something like that. So let's say this is the point. The angle would be talking about here is this angle here, because it's greater than 180 degrees, but it's not a revolution. Does not get to 360 degrees. Our next type of angle is the vertically opposite angles. So this is a proven theorem already. So whenever there is two lines that cross each other like this, or that meet at a certain point, at that point, this angle here, so this angle here is always equal to that angle there, and this angle here is always equals to that angle there, as long as these straight lines AB and CD are straight lines that cross at a certain point. Then the vertical opposite angles are equal. So the opposite angles are equal, as denoted in this, or as shown in this slide. Our next term is supplementary angles. So if you have a line DC, or you name the line anything, AC for instance, and that line is divided into two by another straight line, so forming angles like C, so C and D, and if C plus D is equals to 180, we say that the angles are supplementary. So the angles are supplementary if they add up to 180. Then we get complementary angles. Complementary angles are angles that add up to 90. So if we have A and angle B, if we add them together, angle A plus angle B, and it gives us 90 degrees, we say that angle A and B are complementary angles. And so we get a straight angle. You only get a straight angle when you have a straight line. So in this case, let's say we have line HI and point, let's say B, and there's a point there, we can say, and there's B1 and B2, we can say that angle B1 is 180 degrees because that's what a straight angle is. It adds up to, it doesn't add up, it's just 180. And this makes sense because if we have 180 on B1 and 180 on B2, so angle B2 is also 180 degrees, and 180 plus 180 is 360, and it brings us back to the revolution angle, which adds up to 360. Angles around a point always add up to 360. So if we have a line, there's a 180. So in future, we are going to use this reason, angles on a straight line. Always remember that angles on a straight line add up to 180. And so that is it for this video. Thank you guys for watching. See you in our next video as we tackle some questions to just get the whole concept, to get all the concepts in our heads. See you in our next video. Bye.